Hello, everybody. My name is Monty Paulson. I lead the Passive House team at RDH Building Science. And I'm joining you today under the smoke-filled skies on Gambier Island, just north of Vancouver. If you look behind me, maybe you can or maybe you can't see the water. 2 days ago, it was not even possible to see the tree line right there. So it's been pretty sick for the last week or so. I'm really happy to see you, to come out of the smoke a bit and see so many friends. It's my privilege to welcome you to the Passive House Happy Hour, hosted by Passive House Accelerator. This is an inclusive gathering. We welcome people from all Passive House communities. We welcome people interested in electrification and embodied carbon. And we welcome anyone else who's working to accelerate the transformation of our built environment in order to survive the Anthropocene. So please turn on your cameras. We want to see you. Please turn on your microphones. We want you to make some noise together in a moment. And please join me in raising a glass, peer through the smoky skies, and join in a toast to airtight buildings and MERV 13 filters. The Passive House salute to the smoke top.
Cheers.
16.
Cheers, everybody.
Cheers, all. Here's to easy breathing. Oh.
All right.
Yeah.
Now, cover your coughs, close your mics. We have a great show tonight, including a presentation by my colleague, Marine Sanchez. Now, please let me introduce co-host, Prudence Ferreira.
Hey everyone, I'm Prudence Ferreira, and just doing a quick scan of who's here so far. I think most of you we've met already. But one thing that I haven't really done is explain what I'm actually doing. I lead the Passive House practice for Morrison Hershfield, and there's been some change that's been happening in the industry lately. And part of why I'm at Morrison Hershfield is because of that change. It's a big multidisciplinary building science, envelope consulting and engineering firm with 22 offices across North America. And as familiarity and recognition of the essential role that Passive House plays in mitigating climate risk and providing strong basis for resilient design increases, more large multidisciplinary firms like MH are focusing on Passive House, and larger projects are opening new challenges and opportunities to streamline how we deliver low carbon solutions like PH. But we need more traction. We need more architects, engineers, builders. We need developers and financiers, owners and operators, and most importantly, young people and students, and my dog says dogs too, to understand why Passive House is climate action. Passive House is resiliency. And so I'd like to give you all some homework. First, take some time in the next week before our next happy hour to divine for yourself why Passive House is climate action and resilience. Second, if you have kids, talk to them about it and get their take on things. And third, send a message to one person who's not part of the Passive House community and tell them your thoughts on this and invite them to come to an upcoming happy hour or just check out the Passive House Accelerator. And then fourth, make a 30-second video of yourself and or your kids explaining your take on why Passive House is climate action and resilience. And then fifth, think about how we as a community can use these 30-second videos and our voices to start a social media campaign and get Passive House more visible to everyone is a critical part of the solutions that we need now. And with that, I'm going to hand it back over to Zach with some fun news.
Yeah, fantastic. It's news that is in the same vein. We have a very exciting announcement at the Passive House Accelerator. So drum roll, please, as I pull it up. Passive Buildings Magazine is merging and becoming part of Passive House Accelerator. We're very happy about this. Yeah, woo! You probably know Passive House Buildings Magazine or Passive House Buildings books produced by Mary James. She has been at work writing about Passive House since 2008, and she worked with Bronwyn Berry on her own Passive House retrofit 10 years ago. So she's been part of this community for a long time. And these publications have played a really important role in educating about Passive House. So we are super excited to have Mary join us, her team join us, and to be able to share this original content via the Accelerator. You're looking on the left at an image of the new issue of Passive House Buildings magazine, which will release tomorrow on the Passive House Buildings magazine website, as well as the Passive House Accelerator website. So you're getting a sneak peek. Mary will be writing with us. She'll also be producing a prefab construction and Passive House roundtable event. So we're going to start doing roundtable events with this first installment happening in November. So prefab, retrofits, prefab, all that has been a passion of Mary's. So we'll be able to harness that, and we're pretty excited about it. I want to pause for a moment and invite Mary and Tamara to say a couple of words. Tamara does marketing with the Passive House Buildings magazine, and will be helping us out as well. So Mary.
Hi.
Hey, Mary.
Great to see everybody here, and I'm super excited about joining the community here. And yeah, stay tuned for all of our exciting developments that we're working on. Great to join forces with the Accelerator and, increase our impact and hopefully create greater and greater reach.
Fantastic. Thank you, Mary. And Tamara, are you on the line?
Nope.
Nope. Okay.
She was going to try to call in, but.
All right. Yeah. So I want to invite Michael to say a couple words as well, but I also want to just toast you, Mary, and to all your fantastic work, and welcome to the team. We're looking forward to working with you. Hear, hear.
Hey, hear, hear.
Cheers. Cheers.
All right, Michael.
Actually, I'll just say that I've been reading what Mary's been writing for quite a while. I'm addicted to the magazine, so I'm pretty excited to have kind of the whole team on board. This is a lot of fun. It's great to see everybody coming together. It's going to be a lot of good stuff happening. It's going to be fun. So get ready. That's it.
Awesome.
Hey, I just want to add that photograph on the cover is from a building that Melvin Lau is the architect. Melvin Lau is here on the call somewhere. It's a Passive House multi-unit in Whistler.
Cool. Thank you. All right. So with that, we're going to move into small breakout rooms. So we're going to do our rapid fire 3-minute version of this. So make sure that we get around the whole group and introduce yourselves to each other. We'll be back in 3 minutes. I'm gonna jump into quick announcements, and then we're gonna get to the meat of the program here. And so on the Passive House Accelerator website, we have launched a new feature every Monday, Passive House Week in Preview. And so you can get, this is a summary of the big things that are coming up, according to our viewpoint. So it's a little biased. We have the happy hour, of course, and we have the podcast featuring Chris Benedict and Henry Gifford that you should definitely check out, as well as a bunch of announcements. So save the date for the FIAS Hootenannies in October. That should be really awesome. Information about the International Passive House Conference is starting this Sunday, so you want to get on that for sure and not miss out. And the NAPHN live event that happened yesterday, and of course the socials. So go ahead and some education stuff. So go ahead and navigate to that article for more. Next week also, we're going to do something new, and that is we're going to do an event throwdown at 3:45 Pacific, 6:45 Eastern during the kind of the pre-show, where we have folks come and talk about the key event that's coming up for their organization in the coming week. And we're going to videotape that and share it with the community. So please, if you want to hear about details of events, come join us. And also, I want to share one last thing before I hand it off, and that is we are doing our second Passive House Component Spotlight, and it is with Zola Windows, and they're going to be talking about They're UPVC window options for multifamily buildings and budget projects. And Florian Spear and Evan Anderson will be doing that next Friday. We just shifted the time to be more friendly with Mark's event. So it's now at 11:30 Pacific and 2:30 p.m. Eastern. And with that, I will hand it off to Prudence.
Thank you, Zach.
Or Monty, yes.
That's okay. That's okay. I
Sorry.
really appreciate it. Hey, I just want to add that, you know, the trade show events at the PHI conference are free. You actually, I think you need to register, but you don't have to pay. Some of the events at the PHI conference are discounted. They are offering discounts for students and many others. So if there's any of that conference that interests you, get in touch with PHI and see if you qualify. It's an amazing amount of content coming up over the next several weeks and starting, I believe, I think the trade show actually starts at like 1 a.m. in the morning tonight if you're in Pacific time, much more friendly time if you're in Europe. Hey, just before I introduce Marine, I want to ask for your help. I've been living in smoke for a week. It's got me thinking that this is going to get worse. Unless we completely transform our economy in the next decade, this climate will grow more dangerous for human habitation every decade for the rest of my life. This is as good as it gets, unless we make some change. Like most of you, I understand that we need to rapidly retrofit our building stock to passive house and other zero emissions strategies in order to give our children a chance of surviving climate change. And like many of you, I think, I'm sometimes frustrated that many of my neighbors, well-intentioned neighbors who care about the climate, really don't understand how things connect. And so I invite you to kind of think about what we can do to accelerate the change towards zero emissions building more quickly, specifically what we can do in this call and among this community. Maybe next week or the week after, we're going to open up some of the time in the after hour to kind of debate this, but we're really interested in hearing your ideas about what we can do to help our friends and neighbors who genuinely care about the future understand the role that zero emissions buildings such as Passive House can play in that future. Yeah, so we'll talk about that tomorrow. But first, it is my distinct pleasure.
Yeah, I gotcha.
It is my distinct pleasure to introduce Marine Sanchez. Now, Marine is a French woman with a Spanish name who learned Passive House in England. In other words, she's everything we want in a new Canadian. Marine is an engineer and a Passive House trainer. She's a detail-obsessed energy modeler who's more comfortable in boots and a hard hat. In other words, she's everything we want when we look for people to work at RDH Building Science. When I first started talking with Marine about the possibility of joining RDH a few years ago, I asked whether she had any interest in going to the office we were just opening at that time, our Boston office. And this was her reply. Oh, right, like I'm gonna flee Brexit for Trump. And I knew in that moment she was a great critical thinker. I tried to persuade her to move to Vancouver, but she came out here, took a look around at our fairly bland nightlife and stagnant local music scene. And that is how Marine became the lead Passive House person in Toronto at RDH. As soon as she was aboard, we handed her one of the toughest, most challenging projects at the time, a large 2-building dormitory project at the University of Victoria, which features a commercial kitchen that will crank out 1,000 plates per day. She steered that project through a really difficult design stage review with more than a little help from Elena Reyes at Passive House Institute. And for these past many months, Marine has applied her experience at University of Victoria, not to mention her whole life, to develop this large dormitory at the University of Toronto at Scarborough. I'll let her tell you about that, but first I want to tell you a secret. I have the distinct pleasure to work in a firm of more than 200 incredibly smart people. Don't tell Marine, but she is one of the smartest. And here she is.
Thank you, Monty. Thank you so much. A lot of truth in all of this. One little thing to add, Roberto at PHI has been instrumental as well in terms of the support that he's given us. And by the way, he is back in Italy. It's 1 a.m. there and he's still dialing in. So awesome. Shout out to you, Roberto. Okay, so now let me just share my screen. Okay, you guys tell me when you can see.
Yep, we can see.
Yes.
Okay, let's dive in. So yeah, detailing large passive house projects. So it hasn't been the first one, but this is a new one. It's been going on for, you know, a few months already, and we've learned a lot. So today I've decided to share our experience on the UTSC, so University of Toronto Scarborough Passive House Student Residence. Before I dive in, Monty talked a little bit about RDH, just summarizing what we do. Sorry, the slides are not cooperating. Okay, how's that? Yeah, that works. Okay. So a little bit about RDH Building Science. We do quite a lot of things. You can see we have, our core is back to building enclosure, but we added energy and sustainability. We have a really fun lab in Waterloo doing research and forensic for most of the time. And then a lot of repair, renewal and rehabilitation as well. So we have, as passive house people, which don't really fit into a proper department, we have the opportunity to always sit between the new building team, the existing building team, and the research team, always listening to all the mistakes and lesson learned that we have on our projects and trying to make the next project always better. So this is pretty cool to have all these people to rely on to make sure that we always do better time after time. And yes, we do a lot of passive house, as Monty mentioned. This is the University of Victoria on the left with Perkins and Will, the Nelson Tower in Vancouver with IBI. So we do a lot of this. We work with PHI, with VS, with Living Building Challenge, with CHGBC Net Zero. And yeah, we have a few certifiers, Monty and myself, on the staff as well. So it's nice to be able to see both sides and again keep learning from all the projects that are going through currently in Canada. So exciting all around. Okay, diving into the project. So here is where we're starting. So this is the University of Toronto Scarborough campus, and the rectangle is our project. So you can see there's a lot of work to do. We're currently looking at a parking lot alongside two of the main roads defining the campus. So that will be the first residential building out there, actually. So pretty cool. And giving you a little bit of a program before diving in. So this is a 9-story building. We have a small basement with a few amenities. Then the level 1 is completely defined as a communal space. And the main key in there is the kitchen and servery area. We get a bit of a transition space at level 2 with some residential and some communal spaces such as, you know, student lounges and like spaces where there can be a lot of interaction. And then level 3 till level 9, we're completely splitting into the residential part, which works in different communities. If you can see my mouse here, you can see the 3 different wings. So, you know, east and west, and the central one, which clearly defines communities within the student housing, giving a bit of a better sense of community in that building. One final thing as well before diving into the detail, we are working with a pretty fun or unusual procurement method where we had a compliance team taking the design to 100% DD. So that's a lot of details already, as you all know with Passive House. And shout out to the compliance team led by Handel and Core Architects with Integral, Stephen Winter, RWDI, and Jablonski on the compliance team. But this team had to hand over the design to a contractor team, to a design build team, which is led by Pomelo, a contractor from Quebec. And our role on this project is to be the passive house and building enclosure consultants to that design and build team. And we get to work alongside IBI again, MCW for mechanical and EXP for structural. So you can see a lot of cool people to work with, but there's enough of that project to work on. So don't worry, it's all good. Okay, so with that bit of introduction, let's dive into the details. So how do we detail a large project and how do we make it go across the finish line smoothly? we were handed a pretty cool package at 100% DD. We're talking about R30 till R40 walls, you know, yeah, above grade enclosure. So we're talking about certified windows, certified curtain walls, certified ERVs. We're talking about a box distribution system on the domestic hot water, making it very efficient. And we're also talking about a state-of-the-art kitchen with heat recovery in its ventilation system. So if you ask me from far away, I'm like, I don't think it can get much better from, you know, much better than that. However, diving slowly into all the details, we started to realize that this is definitely a good starting point, but the design doesn't finish just there. We found a lot of little things, and that's what I'm going to dive in right now. Starting with the below grade, which is literally what is happening or what will be happening on site really, really soon. We are always asking for that continuous layer of insulation to be everywhere. But when we start digging in and seeing what is exactly happening in our basement, you can see that, for example, the elevator pits start being a bit difficult because we have the wrong ground conditions, which means that we can't wrap at least the sides of the elevator pits here all the way further down to mitigate the thermal bridge. So not perfect, not quite optimal. So we're like, okay, we'll take that small hit there. Then we started realizing, oh, we also have a few Sunpits hidden here and there. Let me dig them in to see exactly where they are. And they started adding up one after the other until we finally caught them all. You know, blew everybody's mind to ask for a fully insulated and airtight Sunpit, which has never been done before, at least not, you know, with this contractor team. And then same thing again with the below grade detailing, right? We're starting to look at every single perimeter detail, right? That below ground to above ground detail is fairly critical, where we need that insulation all around. And then similarly with the structure that is within the footprint of the building, where again, we're gonna start insulating. Anecdote aside, I had another team meeting today, and again, we get asked, are you sure this insulation makes a difference? And time again, we're like, yeah, trust me, I've played with the model, I know what I'm doing, we really got to do this. But it's okay, I'm glad that we're discussing about this and agreeing that that's the right thing to do. So that's a below grade detailing. You can see that we were supposed to have a continuous layer of insulation, and then it turns a little bit into Swiss cheese between the structure and other things. So taking a bit of a hit every single time, which is not optimal. Now, moving on to the exact opposite. If you start looking at the roof, the same thing happens again. We want that perfect continuous insulation layer, right? High performance buildings have to be like onions, right? You need all these layers of continuous tightness, insulation, all of them not interacting with each other. And yet this is what we got to work with. Roof anchors, we didn't think too much about them to start with. And then with a building this size, we started counting them all the way till 140. So this is 140 connection points with the roof anchors, which weren't greatly detailed to start with. You can see this is a bit of a significant thermal bridge, turned to you know, a better detail with IBI. Same thing again, still damage support. You know, all these pieces that are supporting all the HVAC kit on the roof, they started adding another 45 connection points. And then the windscreen attachment, same thing again, we have a terrace on which people need to be, you know, safely on, plus 31. Then ERV duct penetration, right? Every time we get, the ERV ductwork going through the roof, we're actually having small concrete roof curves that are hanging up. And then I'm not even discussing about the solvent pipes that go through the roof as well, the rainwater leaders as well. So it starts being a bit demanding in that continuity and insulation. For sure, you're maintaining most of it, but that small derating will have an impact firmly, and it keeps adding up. But what is key to remember is that at the end of the day, the best design doesn't matter if it doesn't get implemented, right? Like our job here is not only to design perfectly, but to get these buildings out of the ground and not keep on locking carbon. So when you think about insulation, that detailing around air tightness, the waterproofing membrane as well, that has to go all the way above all these firmly broken pads and all around all the anchors, we are asking, like, this is a tough job for the guys to do that on site. So this is not perfect. We're working hard to find alternative solutions that are completely thermal bridge free and sit on top of a roof insulation, but between different code issues and different, other constraints on the project, we don't always get to do this. So work in progress. Hopefully we get to minimize this as far as we can. Finally, other things that, again, I'm not gonna dive into the details, but it keeps adding up, the solvent pipes, right? It's not supposed to be much, but on a building this size, when you start counting all the meters of drainage pipes, they can add up to a few, kilometers or so. Roof rainwater pipes as well. We're not having a super good drainage system on that side, so we are taking quite a big hit with all these ventilated pipes going through our building. Shading support to be firmly broken, curtain wall glass carriers, which can be easily forgotten, but again, with a very, more heavily glazed and open to the outside level 1, it starts adding up. Gas risers for feeding into the generator, all these little things are really starting to add up on top of the key thermal bridgings that were definitely well detailed from the outstart, right? Ground perimeter, intermediate floors, parapets. So all in all, if I look at this project, I think off the top of my head, the thermal bridging, due to all the things that I've just mentioned, they're adding close to 2.2, 2.3, I think, kilowatt hour per square meter per year. So this is not nothing. It's a fairly significant chunk of your entire, space heating demand budget that gets into there. So this is the size around the detailing. Now, as Monty mentioned, we're going to be the ones supporting Pomelo while being on site, getting that thing built. There's an interesting aspect about around procurement as well. Procurement. Okay, so first thing first. That might make a lot of people laugh, but time and time again, this keeps happening. And this is not because I'm French. It's, that whole way to describe what we're after between the passive house person and the rest of the design team, be it the architect, the mechanical engineer, the contractor, the trades, absolutely everybody. There needs to be a clear understanding of what we're after, just to be able to maintain that performance from A till Z, right? Like, this is absolutely crucial to get us through the finish line with the level of performance that we were expecting. So one thing I want to highlight here is, of course, there's a huge communication effort to happen with the design team. And I have to say, again, we're being very lucky to work with this team. Most of them have done passive house before. It is a smooth ride. But for Pomelo, for the contractor, this is their first time. And what is really important is for them to understand, and for the sub-trades to understand what, to have a clear understanding of what matters. And by that, I don't mean the exact product, because passive house is not tied to exact products per se, but to translate what are the performance targets hidden behind the detailing or the products that are being specified, so that when they come in with product substitutions or alternative ways to build, they can come in with an informed design to the table and help us do this thing better. So I don't have enough time to touch on everything. I decided to share a little bit on Windows today, which was a fun ride. First thing first, language. Well, it all starts with NFRC versus ISO, right? Passive house works back with the ISO standards. NFRC works with slightly different standards, which are based in North America. So it's important to set, you know, the basis of design, what we're working with. So on this note, I'm going to do a quick plug for the Peel Passive House and RDH paper that has done a full protocol paper helping everybody in the industry, manufacturers, to translate between one language to the other so that you can please everybody. That makes me a happy girl when I get that. So that was the first thing, which already took a little while. Then we have passive house frames, right? For both the punch windows as well as the curtain wall. So you'd think it'd be easy from there. Well, what I found is I was spoiled when I was practicing in Europe, because when you ask for a frame and you go onto the Passive House website, the certified product database, you get told you're going to have that frame and that's going to be your spacer and you're all taken care of. You know, you can relax. However, in North America, it seems that the spacer doesn't make it through, you know, across the ocean. So every single time I've had certified frames, I've actually had to have a separate conversation with the manufacturer to say, hang on, I have this on the certificate, but what are you actually getting me? You know, what are you delivering on this project? So again, it's not undoable, but it needs a bit of extra work and being aware of this from day one, not to be get caught at the last minute. This has happened on other projects, UVic and UBCO and other student residents we're working on as well. And that puts us in a difficult position when these changes are last minute, because obviously the margin that we get into the model disappears with time. Bird-friendly glass as well. I thought I had a great, you know, great glass spec. I was like, easy. And then we realized that for the Toronto Green Standard, we have to work with bird-friendly glass. Totally okay, the right thing to do. However, my 0.55, you know, watt per square meter per Kelvin center of glass U value got very easily transferred to a 0.88 on the first quote, where I was like, we're not going to be friends. You might want to take your pencil and try this thing again. And after a bit of discussion, bouncing ideas everywhere to trying to sort it out, we managed to find a clever way. As you can see just on the drawing explaining what this is related to, is that you do need that pattern for the birds on surface number one, which is the external surface, but that has a domino effect on where you can put the lowy coatings that are getting you that great center of glass U value. So that knock-on effect of adding the freak pattern at the beginning led me to, you know, spaces where places I didn't want to go to before going back to 0.556 watt per square meter per Kelvin. Okay, I can live with that. Let me work on my model. Large sizes as well. At an early stages, we don't necessarily talk directly with the manufacturer to say, okay, tell me what is the biggest operable window I can have before we start needing extra support. So same thing again, we got the certified frame. I was all happy. I reviewed the first submittal, and half of my frames had, you know, a terrible frame thermal performance. And I asked a few more questions and I'm like, oh yeah, there's still in there. We can't give it to you that big without this. So again, with a bit of massaging, a bit of workaround, we actually didn't have to change the design, but that was a bit of a work process for them, with the manufacturers to get back to a minimal amount of frames needing that still support, which moves the frame performance from 0.76 to 1 watt per square meter per Kelvin. And finally, I mentioned them before, curtain wall. It's not much, but that little point thermal bridge times 2 per panel times the number of panel on these large buildings add up to quite a bit, especially if they might not be thermally broken or, sorry, non-conductive glass carriers. So you might want to keep that in mind. So in summary, when we're detailing large buildings, you already know the key formula, right? You already know the starting point. We need a great enclosure and we need a performing HVAC system to back it up. However, I would urge anybody working on a slightly bigger project to keep an eye from the very beginning, maybe not on a detailed design, but on the strategies that are being used for all of these small items that start adding up fairly significantly on this project. And secondly, if we look at the procurement, it's absolutely key to be able to extract in a language that everybody can understand these performance targets for the contractor and all the trades working there, so that that communication is, channels are wide open. And then that attention to detail that I cannot emphasize enough, because, we got to start delivering what is on drawings, not just, that's how we did it for the last 30 years, right? So that attention to detail is absolutely critical to get us through the finish line. There you go. That's what I got for you tonight.
Thank you, Marine. There's a sea of questions and comments in the chat we're going to get to in a minute. I just want to echo two things briefly. The link for the paper that RDH and Peel and PHI prepared is in the chat. It is on the Passive House Canada site and others. I was responsible for getting it to Zach to put on the Accelerator site, and I will still do that, but I failed to do that by this moment. So that's on me. The paper actually walks through examples. You could use it as a training exercise to use tools to prepare data appropriate for the European or PHI standards. Secondly, I would just say that, I think what Marine just shared is a great example of what we run into in large buildings again and again. We see that the additive effect of lots of thermal bridges adds up to an awful lot, much more than in ground-oriented wood frame housing. And we deal with trades who just don't believe that this fitting or this other fitting matters. And they intuitively, it just doesn't seem like the roof stanchion or this pipe running through the foundation is going to matter. And so they genuinely believe they can take shortcuts and it won't matter to the building, because how could it? It couldn't possibly add up. And so that tension between an uncommonly amount of thermal bridging and contractors who just don't believe, they can't wrap their heads around the fact it's not intuitive that it makes such a big difference, is what we run up against on these kind of projects again and again. With that, Sean, have you tracked all these wonderful questions and got somebody queued up for first one? Awesome.
Yes, Graham, you're up next, and while he answers the question and comes on, hopefully people are running to get cheese and a glass of wine from all the lovely discussions.
Great, I approve.
Yes. Graham, you there? There you are. You got two questions, so you might as well ask both. So go ahead.
Three. Can I ask all three?
Oh, I didn't see the third one, but I'll give you two. We'll see how you do.
Okay, well, I'm going to pick my most important one is, what were the strategies for domestic hot water production and delivery?
Oh, okay. That's a really good question. So first of all, the distribution system is a box distribution system. So rather than having risers that go, like one way for the flow and a second way for the return, you get only one way for all the flows everywhere. And then you have a common return that goes back. So that significantly reduces the total length. For the rest, we're getting pretty inventive on the domestic hot water heat recovery system. We are using waste heat from, actually, I don't believe the kitchen ventilation, but from the dryers, as well as from all the gray water, so showers, as well as all the kitchen domestic hot water, to go back into a tank to have an active heat recovery to get as much heat as we can out of the gray water. So quite a few bits.
Okay, and question two is, why couldn't you insulate the elevator pit? It looked like there was insulation under the slab, which I would have thought was the most difficult part. Why couldn't the sides just be insulated?
Yeah, Zach, is it okay if I share my screen again?
Sure.
Okay, let me just trying to catch that quickly. Okay, so more or less what is happening is that you're more or less the way to mitigate that thermal risk. So obviously you cannot, the structural engineer will have his eyes popping out if you're trying to link these two bits of insulation. because structurally we can't do that. But the way to mitigate it, which we've done well on another project, is for that vertical insulation to run as far down as you can, to kind of force the heat to have a longer path to escape. So it's not thermal bridge free, but because you're making the path much longer and much harder, it actually mitigates the thermal bridge better. But right now, we need the foundations to be at a certain level linked to the water tables and other things. So the structural engineer worked all his magic, and I asked for everything I could, and this is the maximum I could get. So we're still trying somehow to mitigate the thermal bridge, but this is a pretty poor thermal bridge when it, you know, when it comes to elevator pits. Like if you get better ground conditions, you should be able to do significantly better.
Graham, are you happy?
More or less, yeah. I don't know why the insulation couldn't run up the inside of the elevator pit. What does that have to do with the structure?
Oh, just because of the machinery and stuff like this.
Yeah.
We could ask on the inside, but we find it really difficult. Like we've asked several times, and I'm not sure if we've had it on our projects. It might have happened in other projects, but not on ours, as far as I've been told.
Thank you.
All right, Nathan's up next, and Graham, you can go get some fromage and wine, since people were heckling me for not saying fromage, PH. Enjoy your fromage, everyone. Sorry, Nathan, where are you? You're up next.
So thanks. Thanks, Marine. That was a wonderful presentation. One question I had is, I've been seeing the use of this hardened foam as a thermal break, as a sort of a new product that's out there. I don't know much about it other than I've looked at it and figured out a way to make my windows sit out further using that thermal break, and we've got a solution for that. But I thought maybe that would be something that would work for all those penetrations that you were detailing. Do you want to?
So we do.
Okay.
Yeah. Let me just share. Sorry, too many screens. Let me just share again. Okay. So come on, PowerPoint. You can do this. Yeah. So this is the slide. So we do have all these pads here for all the penetrations that we have. So they are definitely playing a big role, because without them, you would have a highly conductive material going all the way from inside to outside, right? But despite the fact that we do have them here, they don't make the detail thermal bridge free. They minimize it to a certain extent, but you still get a small allowance, and it gets, you know, time and time again, because yeah, that psi value or that chi value that we have with that point thermal bridge is nowhere near, you know, 0.00 something. Definitely use them, but they don't take you all the way to, you know, the magic land where you don't have to account for them.
I see. Thank you.
No problem.
And I'll just chime in. Is that an armor therm or compact foam, or are you guys using something else for a lot of those thermal bridges?
We've been talking about armor therm, but I think this is a slightly different product that was spec'd in the specification, like blast of foam or something like that, like that hadn't worked before, but it seems to do the same type of job. So I'm glad to see that there's more and more available products out there to start doing this type of jobs.
Yeah, we need more. So if anyone knows more, I know even
Sure.
the Glavel will be coming on board in about 6 months, so we're still a little bit further away. Sorry, I think it was, who did I have? Sorry, Yesha? Yes, Yesha Org, you had a question.
Yeah, I was wondering regarding the bird-friendly glass.
Yeah.
We don't really have that requirement here in Cincinnati, or the work that we do, but we work on a lot of federal projects where bullet resistant and blast resistant glass is needed. Does the same sort of issues that you ran into for the bird resistance run into for those?
I'm not 100% sure. I'm going to be honest. I'm not, a complete window guru, but my gut feeling is that if you're not impacting the surfaces that you've got on top of your glass, you're just changing the glass itself, right? I believe it should be okay, but it's definitely a question worth asking straight away with your preferred manufacturer, right? Because it's not as if we're asking them to do anything new. They all work with the same, you know, glass manufacturers, be it Guardian or Saint-Gobain or others like Cardinal, like and others. So we already know the key players, we know what they're able to do. So asking that question early will actually give you the peace of mind that you're not going to find, you know, a bad surprise later on down the line.
Okay, thank you.
Roberto made a comment, and since he's coming in from Darmstadt, I figured he should come on and ask it, and then we can all give him a huge applause for staying up so late. And I wanted to see the
like
dark eyes. Exactly.
He doesn't have video. He doesn't have video on his computer.
Too bad.
Roberto, do you have actually a mic at least? Yes.
Yeah, I have no camera in my laptop.
So we're not seeing all the beers stacked up in front of you because you've been having happy hour for 8 hours. That's what you're telling us.
At least.
Yeah. And yeah, I wrote a comment about the surface, the coating on the interior glaze, glazing on the windows. And I said, usually the center glazing is not tempered or not reinforced glazing, is a normal pane of glass. If you put a coating in this element, you should temper it or increase the resistance of the element to avoid breaking or
thermal stress.
Yeah, exactly, too much thermal stress. And if you do so you must be sure that the glazing is tempered or more resistance than the normal one.
Yeah.
Also because the outdoor glazing and the indoor glazing are in contact with the ambient air, so they can dissipate and lose energy and keep the temperature quite low. But the inside glazing, it's it's really, really well insulated.
Yeah.
Great. I think because I know a couple of comments were about it. So thanks, Roberto. And again, appreciate you staying on and being a huge support to Marine and all of us. So thank you very much.
Welcome. Very welcome.
It's nice to hear you, Roberto.
Yeah, sorry. I'm almost two after also cocktail when you were drinking. I also were drinking as well. And so
I know what happened to that camera. Yeah, cheers to you. Thanks.
Exactly.
We have Tom Phillips and then Tom Balderston, and I think that'll take care of the happy hour. We'll dive in the after hour. So we've got two Toms lined up.
Hola. I had the usual question about overheating analysis, because I know there's a lot of work going on that in Toronto, and whether you did it for future climates and were you able to mitigate it. And then also something I just saw today on a Green Building Advisor or somewhere, where they used kind of the self-tinting glass, sun sensitive or something like that, where they have to special order the glass and put it in the frames, but it's kind of like your eyeglasses, I guess, that change color automatically. And it seems like those might be affordable and dropping in price. And I don't know if anybody's looking at those yet for commercial buildings or not. So those seem pretty cool, pun intended. So.
Well, we have been looking at those on different projects, more high-end projects, but except I would love to be told otherwise, but I think on institutional buildings like this one, the budget won't be there to have anything that of that sort, at least in terms of the IGUs, you know. It needs to come down way further to be able to be added to these types of projects, because we are stretching their budget already. And it's not necessarily Passive House, we're asking for a lot of program as well, but you know, it's already, you know, a big dollar figure. So there's not a lot of space for extras and more fancy stuff.
And then did you do any overheating analysis?
Oh, for the overheating analysis, I have to admit, so I don't know what the compliance team did because we didn't receive any documents on that. But to be fair, we're obviously running everything in the PHPP to start at least having an understanding of what is going on. But that is something that we could do. However, in this case, we've done a lot of that for the University of Victoria because we had higher risks over there. But for this particular project, we already have cooling in every single room. So all in all, it's about sizing the cooling better, not putting people at risk, because overheating should not happen because cooling is already present. So I think for now we should be okay. But if we start seeing the design, progressing in a certain direction where we think we might be borderline, then we would definitely move on to dynamic modeling for the key zones. And as you said, for future climate, we always do it no matter what. So we always have the PHPP ready for certification as per, default input, if that makes sense. But we always have different sensitivity analysis or different cases logged alongside in the model to say, but this is what you should be expecting for future climates, because we more or less playing with the meteo norms and the different IPCC scenarios to create these future decades. So we do have these for Toronto, and we do run them on every single project that we work on. So,
and from what I could tell from PHPP, it looks like they're using monthly averages rather than hourly or dynamic. Okay.
Correct.
Okay.
But it's missing some level of granularity on these types of buildings, because obviously on a single family dwelling, it's totally okay. But moving to these larger buildings that do not function exactly as a one zone system, it is down to us and our common sense to look at the input data and trying to focus on the different rooms, some of them being more at risk. So yeah, when you think that you're reaching that line, then you just drag these spaces out and you do go have a quick look with dynamic modeling for sure.
Okay, thank you.
No worries.
All right, head over to another Tom Balderston.
Hi, thank you, Marina. Just would love to hear more about the state-of-the-art kitchen and where it was mentioned at the beginning, what was done with that.
Yeah, how many hours do you have?
Well, why don't we pause with that answer, Marine? Because
just kidding, Sean. Just kidding.
Well, we could go deep, so I'll give you a minute, and then we're gonna do our kickoff, and we could dive back in the after hour. So go for it.
Okay. So little plug on this. We've been working through the exact same project. Again, Roberto was instrumental at PHI supporting us through that for the University of Victoria kitchen, which is actually not trying to do slightly less than 2,000 meals a day, but does 9,000 plus meals a day. So the biggest, headache I've had for the last year or two. There is a detailed presentation on this for the International Passive House Conference. So I'm presenting on this if ever that's of interest. And I'm going to summarize it in 25 seconds. Let's see if I can do it. Your biggest culprit is your kitchen ventilation. So you have Sean, this is too stressful. I cannot do this. Your biggest culprit is your kitchen ventilation. So you need to reduce that as much as you can, which you can do through a lot of different measures to reduce your max. And then you have to add a demand control ventilation to make sure you are only ventilating as much as you need on a minute by minute basis. Second culprit is going to be all your kitchen equipment. So on this, you're going to need to make sure that you look at all the state-of-the-art equipment, being induction or electrical, fryers, broilers, whatever it is, because that's magical. So again, a lot of work to be done, and this is also heavily related to the client and the client kitchen staff, because we're asking people to change their habits. So that's a tough one. And the third one will be your domestic hot water consumption. Even if it's huge, it's still not as huge as the amount of electricity that this kitchen consumes, but it still needs close attention to it. And you should reuse waste heat to preheat your domestic hot water in any way you can. For the UVic project, we are using dishwashers with heat recovery features, as well as all the refrigeration system, dumping heat in a centralized compressor system that feeds straight away into the domestic hot water preheating tank. So once you've done all of this together, you get to a state-of-the-art kitchen that probably uses between like a quarter to an eighth of what is typical out there when you look at benchmarks. And by the way, despite being typical for the number of meals that we are doing on that project, it still has a total, a total PR price tag of between 500 to 600 kilowatt hour per square meter per year. So I hope you were sitting down, because we clearly need state-of-the-art kitchen, because that's already, like, this is too much energy consumption for my heart to handle. I do not see these figures on a daily basis, and this is state-of-the-art, so I don't even want to think about what we normally tend to deliver on other projects. So there are tools out there, you can do it.
All right, Marine, thank you. And Zach, over to you.
All right, I'm gonna reveal next week's speaker, but before I do, I wanna say some quick thank yous. And if you're wondering how we can make these happy hours possible, how we can do the podcast, how we can do the website and calendar stuff and the programs that we do, it's all thanks to the sponsors of Passive House Accelerator. So I want to thank our founding sponsors, Baxtingby Architects, Mitsubishi Electric, RDH Building Science, Stow Corp, and Zola Windows, as well as our stakeholder partner, NYSERDA, and our patron sponsors, Morrison Hirschfield, 475 High Performance Building Supply, and Partel. Thank you very much, sponsors. Now, next week, we are going to have a special guest, Bill Hayward of the Hayward Score. And you're probably familiar or have heard of the Hayward Score. He has developed a data set of tens of thousands of scores scoring the health of buildings across North America. And he is embarking on a project to document the benefits of Passive House through this score. And we'll talk about that next week, and we'll be invited to participate. And this is a great way for us to prove out the benefits of Passive House. And it's couldn't be more timely given the air quality issues that we're all experiencing. So please join us next week. Thank you. Thank you, Zach.
Thank you, Marine. Congratulations again to Mary and the team at Passive Buildings Magazine. We're really excited to have you as part of all this. I don't know if you can actually see the sun there. Just barely there, this little dot. It's like living on Tatooine or something like that. Thanks everybody for joining. We look forward to seeing you back here next week, or stick around for the happy hour.